In this unit, we learn how to solve linear systems of equations using matrix. The process is called the Gauss-Jordan method. So the first step of the method is to convert the system of linear equation into the augmented matrix form. For example, this equation x plus 3y plus 2z plus 1, we just use the coefficient 1, 3, 2, 1, 1, 3, 2, 1. Same for the other rows, 2, 1, negative 1, 2, 2, 1, negative 1, 2, 1, 1, 1, 2, 1, 1, 1, 2. So these are the columns and these are the rows. With this method, there are transformations that we can use. One, we can interchange any two rows. So row 1, row 2, for example, we can switch. 2, we can multiply or divide the elements of any row by a number, a non-zero real number. 3, we can replace a row of the matrix by summing the elements of that row with a multiple of elements of another row. And we'll see this example in a little bit. So the goal of this method is to get to this final form where the diagonal is 1 and the rest are 0. So 1, 1, 1, the rest are zeros. And the result is, in this case, will be x equals a, y equals b, and z equals c. So this form is also called the reduced row echelon form, RREF. So let's look at this example. Let's solve the system 3x minus 4y equals 1 and 5x2 plus 2y equals 19. So the first step, let's convert it to the augmented matrix form. So using only the coefficient 3, negative 4, 5, 3, negative 4, 1, 5, 2, 19. And the goal is to get to this format, 1, 1 in the diagonals and 0 the rest. So the first step is to get this first number to become 1, top left, right? So 3, to get that to 1, we divide it by 3 or multiply by 1/3. So when we multiply by 1/3, we multiply across the row. So 3 times 1/3, that's 1. Negative 4 times 1/3, that's negative 4/3. And 1 times 1/3 is 1/3. So the next step is to bring this number to become 0, the number at this position. So in order to do that, we subtract. So this row subtract 5 times of this row, because 5 minus 5, 5 minus 5 times 1 would be 0. So we do that with every element. So 5 minus 5 times 1 is 0. So for this element, 2 minus 5 times negative 4/3. So that is 2 minus plus 20 over 3, which is 6 over 3 plus 20 over 3, which is 26 over 3. Then do the same. So this row minus 5 times that. So 19 minus 5 times 1/3. So that's 19 minus 5/3. 19 times 3, that's 57 over 3 minus 5 over 3, which is 52 over 3. So the next step is to get this number to become 1. So we multiply by the reciprocal. So 26 times over 3 times 3 over 26 would give us 1. So we multiply this whole row by 3 over 26. So then we get the last row to be 1 and 2. So the next step is to bring this number to become 0. So we do that by adding negative 4/3 to 4/3 times the second row. So negative 4/3 plus 4/3 times 1, that's 0. So we do the same for this last column. So 1/3 plus 4/3 times 2. That's 1/3 plus 8/3, which is 9/3, which is 3. So now we get into the RRAF form. So we can conclude that x is 3 and y is 2. And we can also check the solution into the original system. 3x minus 4y equals 1. 3 times 3 minus 4 times 2 equals 1. So that's 1 equals 1. And with 5x plus 2y equals 19, we get 19 equals 19. Go ahead and try this to solve this system using the Gauss-Jordan method, and here's the result.